Hi guys, welcome back to my channel. So this is the part 4 of this video. If you guys want to check the other parts, then do check out the link in the description below. Okay, so we have this here. It is always the case that phi is true or always true when x is true. Okay, and we need to write the formula of this one. Okay, so how do we even do this? Okay, you need to read it carefully, that it's saying if phi is true. Okay, so that means first of all, let's go ahead and try to like see how many possibilities you can have. Okay, what are they actually asking? So they're asking if phi can be true. Okay, so phi can always be true, or it's always the case that x is true. Okay, so we can have this true. Okay, so if this is true, that has to be false, right? Or we can have the case when this is true, when x is true. So if x is true, that means that has to be false. Okay, so before writing the formula, I'm just like examining the possibilities we can have, so it will help us write the formula. Okay, and or always the case when both are false. Okay, so we can have the case when both of them are false. Okay, so we can have another case. Okay, so these are the possibilities that are possible in this scenario. Okay, we can have like true at the either side of them or false. So what are the possibilities that we're missing? Okay, because if we're allowed only to have this and we need to write it in terms of a formula, that is going to be a hard job. Okay, so instead we can focus on what we don't have, and we can write a negation to that, like excluding that, so that will eventually give us this, right? If it doesn't make sense, let me do it so it will make a little sense. Okay, so what are the options that we are missing? We're missing true and true, right? The case when a phi is true and x is true as well, which doesn't include in here, right? So let's go ahead and write the formula to this, right? So when can we have both of them true? When there's an and, right? When there's an and, that means both of them are true. Okay, and we do not want this case. We want the case when we do not have this. So which means what? We have all this, right? So we're just going to negate it. Okay, so if you negate this, you're going to receive this, which is what you want in this scenario. So exactly, that's what you got over here. But if you guys want to go ahead and solve it further, then you can write it in terms of like this as well. If you distribute the negation, so then it's gonna come in front of the phi, and this and is gonna become or. Remember, because if you're multiplying with the negation, then that becomes or and not x. Okay, so that's how you write it. You can write it either way, but I think this one is better because it's distributed. Okay, so let's leave it like this. Okay, so then what do we have? We have if, and then we have then. So that's an implication, if then. And remember guys, it has if it is always the case, and the formula for always in the predicate logic, it looks like this one. Okay, so you're just going to write an always symbol at the front of it, because it's saying like always and then again always. Okay, so it implies to both of them. And then it is infinity often. Okay, infinity often, you guys simply need to memorize this, that infinity often, it looks like this. Okay, so you have like the always, and eventually if you just combine it, so it becomes infinity often. Okay, so infinity often, and then pi becomes true and remains true until, so the sign for until, it's like this, but not including the time when lambda becomes true. Okay, so pi becomes true, and then until the time when lambda becomes true, and that is your final answer. Thanks for watching. Bye.